this is where we were last time. In that video, we looked at the derivative of inverse implicit function. Let z is equal to a function of x and y, where u is e to the x cos y, v is e to the negative x sin y. Now we're supposed to find these partial derivative of delta x with respect to u, delta x with respect to v, delta y with respect to u, delta y with respect to v. So we looked at the general format here, and we found delta u by delta x, delta u by delta y, delta v by delta x, delta v by delta y. Now remember, what we are supposed to find in the end is delta x by delta u, delta y by delta u, right? Also delta x by delta v, delta y by delta v. We're supposed to find delta x by delta u, though we know delta u by delta x, and so on, right? Now here we had look the general form, and we substituted these in the general form. For example, delta u is e to the x cos y times del u. Change in u, small change in u, is e to the x cos y times small change in x, and so on. Alright, so we end up with these two equations, equation 1 and 2. We multiplied so that we eliminated del x to get del y. Now let's redo this thing, but in this case we're going to eliminate del y to get del x. So let's erase these, what we have here. Now equation 1, we're going to multiply equation 1 by this and equation 2 by this. So here we have equation 1 multiplied by e to the x sin y. What's going to happen here now? This is going to be e to the x cos y times e to the, it's negative x, negative x, not x. It's by e to the negative x. Alright? So e to the x cos y, as we have here, we have e to the x cos y times e to the negative x cos y. So e to the negative x cos y. And then we have our small change in x minus, alright, this is e to the x sin y times e to the negative x cos y by our small change in y is equal to, that's going to give us e to the negative x cos y times small change in u. Good. Now equation 2 times, so we had equation 1, hold on, what did we say equation 1 was by again? Equation 1 was multiplied by this, by e to the negative x cos y, right? So equation 1 multiplied by this e to the negative x cos y. So we had e to the x cos y times e to the negative x cos y delta x plus, not minus e to the x sine y multiplied by e to the negative x cos y times delta y, right, is equal to, and then we had e to the negative x cos y times delta u. Good. Now we want equation 2 to be multiplied by e to the x sine y, which is this. Multiply the equation 2 by this. So we have negative e to the negative x sine y times e to the x sine y times, oh, we multiply this part first, my. Alright, so let's go again. It's this times this, right? This times this. So it's e to the x cos y, which is this, times this, which is e to the negative x cos y, and then we write down our small change in is equation 2. Oh no, mixing up myself here now. Is equation 2 by this, right? So I have to go again. Is equation 2 this times this. See it? Alright, so it's negative e to the negative x sine y times e to the x sine y, alright, and or delta x here. So you see that? It's e to the negative x sine y times e to the x sine y times delta x, alright, plus what we have now is going to be this time this time this. We are this time this, now it's this time this. Alright? So it's going to be e to the negative x cos y, which is this, multiplied by this now, e to the x sine y, and then we write down our delta y here. Alright, delta y is equal to, okay, so then after this it's going to be delta v times e to the x sine y. So e to the x sine y, I mean del v, not delta v, del v. Alright, so we have that. So we have our two equations. Alright, so let's review. Equation 1 by e to the negative x cos y. So what we have, e to the x cos y times e to the negative x cos y, changing x, minus, and e to the x sine y times e to the negative x cos y times changing y equals e to the negative x cos y times changing u. Good. Then equation 2 by e to the x sine y. So it's negative e to the negative x sine y times e to the x sine y. Good. We have our change in x plus, then our e to the x cos, e to the negative x cos y times our e to the x sine y. times our change in y equals, and then e to the x sine y times our change in v. So we have that. Now, notice we can rewrite this part. What we have? We have our sine y, our e to the negative x, our e to the x, and our cos y, and our del y. So we see that this and this, they are the exact same thing, except of course for the minus sign. So let us add them together and see what happens. We're going to have these two new equations. If we want, we could call this equation 3 and this equation 4, right? And we say equation 3 plus equation 4. So what's going to happen here now? When we add them, we're going to have, let's put sine and cos e to the x cos y. Let's rearrange this in the meantime. This is e to the x, e to the negative x, cos y, cos y, cos y, cos y is cos squared y, times our del x. Now, plus, then we have our negative. It's a plus negative, so it's going to be minus e to the negative x, e to the x, let's put these side by side, e to the negative x, e to the x, sine y, give us sine squared y times our del x. See that? Alright. Plus what now? Now you see this part, even though it's gone, let's rewrite it as it is and then show that it is gone. So it's e to the x, e to the negative x, sine y, cos y, by our delta y, alright? It's going to be, well, there's a minus sign there, so it's minus, right? This is the minus sign there. Plus now, plus this, plus e to the negative x, e to the x, alright? Sine cos, so it's sine y, cos y. See that? We have our sine y, cos y, and then our del y. See that? Let's erase this from our previous work. This is equal to, and we'll add these. When we add these, we have e to the negative x cos y, change in u, plus e to the x sine y, change in v. Good. Now, here, e to the x by e to the x is 1. So this part is gone. Alright? We have cos squared, change in x, minus e to the x by e to the negative x by e to the x. That's gone as well. We have sine y by del x. But you see the del x, that could be factored out. So we have open bracket, open and close brackets. Oh, this is square. And our del x out here. minus what now? Let's see what happened here. E to the x, negative x by e to the x, that's 1. So that part is gone. E to the negative x by e to the x, that's 1. So that part is gone as well. Negative sine y cos y delta y. No, I mean, negative sine y cos y del y plus sine y cos y del y. That's gone, you know. All of this is gone. It disappears. So all we have is equal. Equal to what now? E to the negative x cos y del u. So it's e to negative x cos y del u. What happened here now? Plus e to the x sine y del v. Plus e to the x sine y del v. Alright. That's what we have. So our del x is equal to e to the negative x cos y del u over cos squared y minus sine squared y. Alright. Plus e to the x sine y del v over cos squared y minus sine squared y. So we have that. But we have trig identity here. Alright? Cos squared y minus sine squared y. Let's look at our trig identity table here. So the double angle identity says cos squared theta minus sine squared theta is cos 2 theta. Alright? So that means cos squared y minus sine squared y is cos 2y. So we can change this to cos 2y. This is cos 2y. This is cos 2y. Alright. Now, the general form for a change in x, small change in x is equal to the partial derivative of y with respect to x times, of u, I should say. Partial derivative of u is the third variable. A small change in x is partial derivative of u with respect to x times a small change in u, right? Plus partial derivative of u with respect to v times a small change in v. Now remember, this is like saying that the amount of money that you are paid is equal to, let's say you have a rate of change of money you're being paid, let's say 5,000 per day. That's change of money, derivative of money per day, times a change in days. So you pay for 3 days, you work for 3 days, plus you get another contract. You're paid $3,000 per day times, and you work for 7 days. Something like that. Alright. This would be $15,000 plus 21,000. So this would give you what? 36,000. Yeah. Just a reminder of the meaning of this general format, alright? But then let's look at this. We have our del X here, our del U, our del V. What else do we have? We have this. So when you compare them, you see that delta U by delta X is equal to e to the negative X cos Y over cos 2Y, and delta U by delta V, right? I mean delta U by delta Y. Where I put Y? My delta V. I mix up myself in doing this part. Alright, let's look back at it. Delta U by delta X. Delta X, no, not delta U by delta X. I need to rewrite this part again. I guess when you wake up very early in the morning, like 2 o'clock, 2 o'clock hours, after a few hours you become confused, start making mistakes. Maybe that's what's happening to me. But anyway, let's redo this part. Here, change in X is the rate or the partial derivative of X with respect to U times a small change in U plus, let me give it some space. I'm going to write something else there. Small change in U plus the partial derivative of X with respect to V times a small change in V. I want to write the U and V clear so that I don't mix them up again. Alright, so as I was saying, it's like this is a small change in the money you collect is equal to the money per day, change of money per day, $5,000 per day times 3 days plus, then you have $3,000 for the next contract per day times 7 days, and you calculate how much money you get. So this is the rate of change of money per day, rate of change of X with U, with respect to U, right? Change of money by day times number of days, change of X by U times number of U's, a change in U. So it's something like that. So you see what I'm saying here, right? The derivative. So change of money, change of or the rate at which you're paid by day times the change in days. This is the rate at which X changes by U times change in U. Alright, so you get the idea there. Just a reminder there. Alright, so back to this thing where you have, you see this and this is the same thing, you know. Notice this and this is the same, this and this is the same. So this and this would be the same. And the same argument applies over here. Same thing here. Same thing here. Alright? So here. That means partial derivative of h with respect to u is equal to e to the negative x cos y by cos 2y, and the partial derivative of h with respect to v is equal to e to the x sin y divided by cos 2y. See that? Now remember at the start we found dv by dx to be minus e to the minus x sin y. That was dv by dx. Oh, let me put this over here for comparison. And then we found du by dx earlier. Du by dx was what? Du by dx e to the x cos y. Alright? So du by dx was e to the x cos y. But guess what now? Well, jump back all over here, man. Alright. So du by dx is e to the x cos y. dx by du is not 1 over e to the x cos y. dx by du is e to the negative x cos y over cos 2y. Different thing. Alright. Same argument applies here. Let me say that again. Du by dx was e to the x cos y, but dx by du is not 1 over e to the x cos y. You don't just flip them over like that. Right? It's not the reciprocal. So du by dx is e to the x cos y, but the x by du is e to the negative x cos y over cos 2y. So remember now, this is inverse functions. The inverse. Usually you would have said du by dx, but this is now the x by du instead of the du by dx, right? Can find du by dx, which we did. Du by dx is e to the x cos y, but here we're supposed to find the x by du, so that's inverse. Alright, so doing this straightforward as it is, you see the amount of work that had to be done, right, in finding all of this. Now what we're going to do in a later video is develop a somewhat shortcut method of doing this, which is referred to as the Jacobian. We're going to find certain determinant that is called a Jacobian. So I'll see you then.